Alright, so coming to the second session, we'll be learning this technique of spotting cyclic quadrilaterals. Cyclic quadrilaterals. Now, you must not feel like circle geometry came out of nowhere in triangles. This is something we'll be using in problem solving involving angle chasing and a lot other things. This is a very popular technique that we use. So, it's important for you to know and understand this, and that is why I'm telling you. So, I'm sure you know what a cyclic quadrilateral is. It's something, a quadrilateral, all four vertices lying on a circle, that is what you call cyclic. This is the easiest way to spot one, to recognize one. But you won't always have a circle to help you. So the first thing that we observe if you don't have a circle is in a quadrilateral. Let's say this is a quadrilateral ABCD, and if the sum of the opposite angles they add up to 180, this and this, D and B, angle A plus angle C is 180, then the quadrilaterals are cyclic. So you don't need to have a circle. Don't need to observe that A, B, C, D if they're lying on a circle or not. If this is happening, then the quadrilateral is cyclic. Now, coming to the second thing, that is the important one. Before that, I'll be telling you this theorem that you need to know. The theorem says that angles subtended by the same or equal arcs, chord, or segment at the circumference of the circle are equal. Now, you must be knowing what's a chord, right? And an arc as well. What's a segment though? This thing you see here, this is the arc, and this whole thing, this is the segment. This is the smaller one. You must be able to observe that this we have a bigger one as well. You call that major segment, and the smaller one as minor segment. And same goes for arcs as well. Now the theorem says that the angle subtended by the same chord or the same arc or the same segment, it's the same thing as you see. I can make them subtend angles at the circumference, right? I can make them subtend multiple angles, as many as I want to. The theorem says that all of them are going to be equal. So all these angles, theta, 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 these are going to be equal. That is what the theorem says. For now, I want you to just remember this. We'll be doing the formal proof of this theorem in circle geometry. For now, just know this. Now, coming to cyclic quadrilaterals, how are we going to use this to recognize, to spot a cyclic? So if I just draw the diagonals of a cyclic quadrilaterals, you'll be able to observe that AB, all these sides are acting as chords, and AB, if you look at AB, the blue one, it is subtending the blue angles. The same chord AB is subtending blue angles. So according to our theorem, they're going to be what? Equal, right? Same goes for the green one. Look at AD, the green one. It is subtending the green angles on the circumference. So these are also going to be equal. Same goes for the orange one and the sky blue ones. This one. So if you see something like this, if you see even a single pair, let's say this is something of this sort is given to you. Now if it is given that this angle is equal to this, then you should immediately conclude that ABCD is cyclic. You don't need to look for any other pair. If even a single pair is given, then that will make this quadrilateral cyclic. Perfect. That is how you spot. This is the most important one. People struggle at this one, so you need to focus better. Now, based on this technique of spotting cyclic quadrilaterals, I'll be doing a problem, a very interesting problem. Here you go. So you can pause the video and try the problem first. We are provided in the problem with BE and CF as the altitudes of triangle ABC, and we have O as the point of intersection. Let's call this O. Now we have to take any line KL through O with K on AB and L on AC. We have K on AB and L on AC. Perfect. and we have KM perpendicular to BE and LN perpendicular to CF. We have to prove that FM is parallel to EN. Now, forget the problem. First of all, when you see something of this sort, where you have to prove two lines to be equal, any two lines to be equal, immediately your mind should go on this diagram from middle school. You must have seen this, right? Two parallel lines and another one intersecting them. We used to call this what? Transversal, right? And when this used to happen, we had what? We used to find a lot of angles, pairs of angles. Let's say this one. Let me use a different color. All right. So this angle is equal to this, and this also is equal to this. These two were referred as what? Alternate interior angles. This and this were referred as corresponding angles. So we used to find these pairs, alternate interior, corresponding, and they used to be equal. We were given two parallel lines. Now we have to prove that two lines are parallel. Now, can I say if I can find these angles to be equal, then I can conclude that the two lines are parallel? Perfect. So I'll have to find two pairs of maybe alternate interior angles or corresponding angles and then prove them to be equal in order to prove that FM is parallel to E. Now, what's the first requirement in order to find these angles? I need a transversal, guys. I need a transversal. Do we have a transversal? These are the lines that we are supposed to prove parallel. This is FM and we have EN, right? Notice that FN is acting as a transversal. FN, FN. These are the lines we are supposed to prove parallel, and FN is acting as their transversal. Let's just say. Now, if we prove this angle to be equal to this, are we done? That would be what? Alternate interior angles. If that happens, then we are done. We'll conclude that these are parallel. All right. So this is just a part diagram. We make this when the diagram gets difficult. Yeah. So you need to learn doing this. It's the same thing. These quadrilaterals. Now, I want you to spot cyclic quadrilaterals from the diagram. They're very easy to spot. Like you see this angle 90 and this angle is 90 as well. This whole thing, right? So the opposite angles add up to what? 180. So we conclude that the quadrilaterals MOFK and what else? This one as well. This one ELNO. These are what? Cyclic, right? So we have to chase this one angle. All right. So by the theorem that we just studied, if you see this angle is being subtended by MO, so this will get transferred here as well because this angle is also subtended by MO. So these are going to be equal. Now, if you observe KM, this line KM, what's the goal? We need to transfer these angles to this quadrilateral, from this quadrilateral to this one, right? So for that, we'll have to observe Km. Notice that Km is parallel to ME, sorry, perpendicular to ME, and EL is also perpendicular to ME. EL is also perpendicular to ME. Km is also perpendicular to ME. So these two are perpendicular to the same line, ME. It is exactly like what we did in the session 1. The prime meridian and all the longitudes basically were perpendicular to the equator, and hence they were parallel, or as we assume in Euclidean geometry. So we are doing that. So we'll conclude that Km is parallel to EL. Right. Now since they are parallel, now we have got parallel lines, we'll look for what? Transversal. What's the transversal here? Look at KL. KL is acting as what? A transversal. KL. Right. And if you see Y is what? One of the alternate interior angles. Which one's the other? This. So Y gets transferred here. perfect. Now observe, using the theorem, in this quadrilateral, which is also cyclic, I can say that this angle is also y, right? This angle is also y. Why? Because both of them are subtended by the same common chord, that is EO. So we have proven that this angle is equal to this. And that is what we needed to do in order to prove that FM is parallel to EN. And we're done with the problem. So I hope you understood at first the problem, and I want you to make remarks from this. So if you're supposed to prove two lines to be parallel, let's say any random two lines, AB or AB parallel to PQ, what's the first thing you'll look for? Transversal. Why? Because you need to prove some angles to be equal. You need to find something proving which will make sure that this gets proven. So what is that thing? That thing is angles. And for the angles you need what? Transversal. So first thing you look for is transversal. Then angle chase, using angle chasing, using techniques like this, spotting cyclic quadrilaterals, using congruency and all other things, you prove those angles to be equal, and then you conclude that the lines are parallel. So this is the sort of remark that you need to make from this problem. So whenever you encounter such thing, parallel proving in future, you should be able to do this.